Hello viewers, welcome to UNC Digital class. In today's class, I am going to discuss about one example of AVL tree. In our last video, we have already discussed about the AVL tree, which is a balanced tree, and in that AVL tree, we have to insert the node in that AVL tree, and if the tree is imbalanced, then in that case, we will be perform different rotations to balance the tree, that is left to left rotation, left to right rotation, right to left rotation and right to right rotation. By performing different rotation, we can balance the tree if after calculating the balance factor of every node those are present in that tree having balance factor then +1, -1 or 0. That means that may be +2, -2 or more than it's. In that case, we must balance the tree by performing different rotations. So, let us see one of the example, and we will be insert the node, and if it will be exceed from its balance factor, then we will be rotate the node to balance the tree. Let us consider this is our number of nodes which is to be inserted into the tree to form a AVL tree, and first the nodes are H, I, J. So, first we will be insert H. So, when we insert H, just calculate the balance factor of this node, as there is no node is present at the left subtree and right subtree of this node. So, the balance factor is 0. And second we will be insert the next node, that is I, as I is greater in the alphabetical order of H. So, it will be inserted at the right subtree of the node H. So, when we insert I, let us calculate the valence factor of these two nodes. The valence factor of this node is -1 because left subtree having 0 height and right subtree having height 1. So, 0 minus 1, that is -1, and the valence factor for the node I is 0, okay, because there is no node in left subtree as well as in the right subtree. Then our next node is J. So, as J is greater in alphabetical order from H and I, so it will be inserted at the right subtree of this tree, okay. So, J is inserted at the right subtree, right node of the tree, and when we insert the node at the right subtree, right node, then if the balance factor exceeds from -1 or +1 or 0, then in that case we will be perform the RR rotation. So, let me first calculate the balance factor for each and every node. Those are present in this AVL tree. So, balance factor for this node is 0 because there is no node in the left subtree as well as in the right subtree. So, the balance factor for the node J is 0. Then the balance factor for node I is -1 because left subtree height is 0, right subtree height is 1. So, 0 minus 1, that is -1, and the balance factor for the node H is -2 because in the left subtree there is no node. So, height of the left subtree is 0 and height of the right subtree is 1 plus 1, that is 2. So, 0 minus 2 is -2, okay. So, when we insert the node J, which is the right node of the right subtree of the node H. So, we can see the node H is unbalanced, or the balance factor which is exceed from -1, 0 and +1. So, now we will be balance the tree because one of the node having balance factor is -2. As we are inserting J as the right node of the right subtree, so in this case we must perform RR rotation, okay. On inserting the above element, especially the case of H, the BST became unbalanced. That means we know that AVL is similar to BST, that is binary search tree, and when we insert the node, that is the BST, because in case of BST it does not need to balance the tree, but as we are performing to create the AVL tree, so in this case as the tree became unbalanced, so the balance factor of this node is -2 since the BST is right skewed, and we will perform RR rotation on node H. And when we perform RR rotation on this node H, what will be the tree becomes? So, this is the tree becomes, that means when we rotate it, you can see I becomes the root node and H becomes the left subtree of this node I, and J is the right subtree or right node of I as usual, okay. So, this is the tree after rotating in RR rotation or right to right rotation, and after rotating the tree became like this, and as this is a balanced tree, so the balance factor for each and every node having 0, -1 or +1. Okay, let's calculate the balance factor for all the nodes. These two nodes, that is H and J, having balance factor 0 because there is no node in the left subtree as well as in the right subtree. So balance factor for the node I is also 0 because height of the left subtree is 1 and height of the right subtree is 1. So 1 - 1 is 0. So balance factor of this node is also 0, and we have seen that the all node having balance factor is 0. So we can say the tree is balanced. Okay. So in next node is B, which is to be inserted in this AVL tree. So B, as per the alphabetical order, so B compare with I, as B is less from I, so it will be inserted into the left subtree of the node I. Again B will compare with the alphabetical order of B as well as alphabetical order of H. So according to that, so B will be inserted at the left subtree of the node H. And when we insert B at this node, what will be the T? What is the balance factor? That the tree is still balanced or unbalanced. Let's see it. So when we insert B, so B will be inserted at the left subtree of the node H. So after inserting B, let's calculate the balance factor of every node. Those are present in this AVL tree. So balance factor for B is 0 because there is no node in left subtree as well as right subtree. That means still we are not inserting A. Okay. So next let's calculate the balance factor for the node H, having left subtree height 1, right subtree having 0. So 1 - 0, that is 1. And the balance factor for the node I is 1, 2, and here right subtree height is 1. So 2 - 1 is 1. So we can see the tree is balanced after inserting the node B. So next node is A. Okay. So similarly, when we insert A, just compare the alphabetical order of A with the root node of the AVL tree. So alphabetical order of the node A is less from I, so it will be inserted at the left subtree. So again it will be compared with H, then again it is less from H, so it will be inserted at the left subtree. Again A is compared with B, the alphabetical order of A and B will again compare, as it is less from B, so it will be inserted at the left subtree. Okay. So when we insert A at the left subtree left node, then let's calculate the balance factor, then we will be confirmed about the tree will balanced or unbalanced. Okay. So A having balance factor 0 and B having balance factor 1 because left subtree height is 1 and right subtree height is 0. And H having balance factor, left subtree height is 1, 1, that is 2, and right subtree is 0. So 2 - 0, that is 2. And you can see here the balance factor H is 2. So it is unbalanced. Again calculate the balance factor for the node I. So height of the left subtree is 3 and height of the right subtree is 1. So 3 - 1 is 2. So you can see this node is first unbalanced. When we insert the node A, and A is the node which is inserted as the left node of the left subtree of the node H. So as we are inserting as the left subtree left node, so in this case we will be balance the tree by performing LL rotation, that is left to left rotation. When we perform LL rotation, the tree becomes like this. This is our tree after performing LL rotation. So B becomes root node and H will be the right node of the node B and A is the left node as usual. Okay. So let's calculate the valence factor. You can see the valence factor of the node A is 0 and the valence factor for the node H is 0, as well as the valence factor of the node B is also 0 because having left subtree height 1, right subtree height 1. So 1 - 1, 0. And again the valence factor for this node, that is 1, 2, left subtree height and right subtree height is 1. So 2 - 1, that is 1. Okay. So we can say the tree became balanced. Okay. So next node is E, which will be inserted in the AVL tree. Again compare E with root node. as it is less as per the alphabetical order, so it will go for the left subtree. Again he will compare with B, so it is greater as per the alphabetical order, so it will be inserted at the right subtree. E is again compare with H, it is less in alphabetical order, so it will be inserted as the left subtree or left node of the node H. Okay, let's see when we insert E. So when we insert E, you can see it will be inserted at the left subtree. It is inserted at the left subtree, and when we insert E, you can see the valence factor of H is 1, the valence factor of B is -1, and the valence factor of I is +2. Okay, so as we are getting the valence factor for the node I is +2, so you can see the tree is unbalanced, because we know that if the valence factor of any node which is present in the AVL tree having valence factor exceed from +1, -1, 0, then we can say the tree is unbalanced. Okay, and when it will be unbalanced? When we insert at the left subtree right node. Okay, so it is inserted. So we can see in this case we will be perform two rotations, that is LR rotation as well as RR rotations. So first we will be perform RR rotation. When we perform RR rotation, what will be the tree? And after performing RR rotation, then next we will be perform LR rotation. Okay, so let's see. So first we will be perform RR rotation on node B. When we perform RR rotation on node B, the tree becomes like this. You can see. So B is the root node, and at the left subtree of B is A, and the right subtree of the B is E. Okay, and H will move as the root node of the node B. That means H will become the root node, and B becomes the left subtree of the node H, and A is as usual the left subtree of the node B, and the node E which is inserted, and after inserting the tree is unbalanced, that becomes the right subtree of the node B after performing the RR rotation on node B. So this is our tree after performing RR rotation, and still we have the tree is unbalanced because we have to perform two rotations, and again we will be perform LL rotation on node I. Okay, so when we perform LL rotation on node I, you can see the tree like this. That means when we perform, H is the root node, okay, and I becomes the right subtree, and the right node of the I becomes same as the right node of the I, and the node which is present as the left subtree of the node H became same. Okay, only H will move as the root node, and I is the right subtree of the node H after performing LL rotation. So after performing the two rotations, that is RR rotation, right to right rotation and left to left rotation, the tree becomes like this, and let's calculate the valence factor of every node, that the tree is balanced or unbalanced. So the valence factor of the node E is 0, A is 0, and also B is 0 because the height of left subtree is 1 and right subtree is 1. And the valence factor of the root node is also 0 because the height of the left subtree of the root node is 2 and right subtree is 2. So 2 minus 2, that is 0. And again height of the node I which was unbalanced. Okay, let's calculate the valence factor, that is the left subtree height is 0 and right subtree height is 1. So 0 minus 1, that is minus 1, and J having valence factor is also 0. So all the nodes those are present in this node having valence factor 0 or minus 1. So you can see the tree is balanced. Okay. So next we will be insert the next node, that is C. When we insert C, let's compare C the alphabetical according to the alphabetical order. So C will be inserted at the left subtree of H. Again C is compared with B, so it will be inserted at the right subtree of B. Again it will be compared with E. So as according to the alphabetical order, so C will be inserted as the left subtree of E. So when we insert C, the tree like this. Okay. So when we insert C, let's calculate the valence factor. The valence factor is minus 1, plus 1 or 0. So in this case we need not to balance the tree. So when we insert F, After inserting F, the tree is still balanced, but when we insert D, the tree is unbalanced. Okay. So let's compare D. So D is compared with H as it is less in case of alphabetical order. So it will be inserted as the left subtree. Again D is compared with B. So it is greater according to alphabetical order of B. So again it will go for the right subtree. D is again compared with E. So it will be less from E in case of alphabetical order. So it will go for C. So D is greater in case of alphabetical order. So it will be inserted as the right subtree. Okay. It will be inserted as the right node. And when we insert D, let's calculate the valence factor of all the nodes those are present. So the valence factor for the node D is 0 because there is no node in left and right subtree. So the valence factor for the node C is -1 and for E is +1 and D, F is 0 because there is no node in the left subtree as well as in the right subtree. So the valence factor for the node B, okay. So height of the left subtree of the node B is 1 and right subtree having height 1, 2, 3. So 1 minus 3, that is -2. So this node is unbalanced or having valence factor +2. Okay. When we insert at the right subtree left, so this node is unbalanced. Okay. And again the valence factor for this node is also -2 because the height of the left subtree of this node is 1, 2, 3, 4 and for the right subtree that is 1, 2. So 4 minus 2, that is 2. So this node is unbalanced and as well as this node is unbalanced. So next we will be rotate the node to balance the AVL tree. So we will be performing RR rotations. Okay. When we rotate LL rotation on the node E, okay, this is the node and we will be rotate it on LL rotations. When we perform the rotations, you can see H, B, A are as usual in the same position and this is our rotation. C becomes the root node of the node E, means E is the right node and D, F are the left node and right node of the node E respectively. Okay. Then next we will be perform RR rotation on node B because after performing LL rotation still the node having valence factor -2. Okay, this node, that is node B, having valence factor -2. So we will be perform again RR rotation on node B. When we perform RR rotation on node B, you can see this is our tree becomes. That means C will move to the root node and B becomes the left subtree and A is as usual the left node of the node B and E, D, F are as usual in the same position of the node C, that is the right subtree of the node C. After performing LL rotation on node E and RR rotation on node B, the tree becomes like this. Okay. Let's calculate the valence factor of each and every node those are present in this AVL tree. So the valence factor for the node DF are 0, 0 and the valence factor for the node E is 0 and the valence factor for node A is 0 and the valence factor of the node B is 1 and the valence factor of node C is 0 and the valence factor of the node H is 1. Valence factor for the node I is -1 and valence factor for the node J is 0. So you can see all the node having valence factor either 1 or 0 or -1. So you can see the tree is balanced. Okay. So next we will be insert the next node, that is G. When we insert G, let's compare G according to the alphabetical order. So as for the alphabetical order, so it will be inserted at the right node of the right subtree of the node C. Okay. So when we insert G, let's calculate the valence factor. The valence factor of all the nodes, that is A, D, G and J are 0 because this node don't have any left subtree or right subtree, and the valence factor of the node B and E, F, C having 1 or -1, but the valence factor of the node H, which was the root node, having +2 because the height of the left subtree of the node H is 1, 2, 3, 4 and right subtree height is 1, 2. So 4 minus 2, that is 2 plus 2. So as we are getting plus 2 as the valence factor of the node H, so we can see the tree is unbalanced. Okay, so in this case we will be perform the RR rotation or LR rotation, that is RR and LR rotation. That means on inserting G in BST became unbalanced as the valence factor of H is 2. Since we travel G from H, we will find inserted in the left subtree of the right subtree of H. We will perform LR rotation on node I. That means we perform RR and LL rotation. So after performing RR and LL rotation, the tree becomes like this. So first we will be perform RR rotation on node C. So when we perform RR rotation on node C, the tree became like this. So after performing LL rotation, the BST is like this. That means it is balanced. So you can see this is a balanced AVL tree. So next node is K. So in the same process, K will compare with the root node and according to the alphabetical order, so K is inserted as the right subtree right node. When we insert K at the right subtree right node, this node is unbalanced because having valence factor minus 2. So as we are inserting at the right subtree right node, so we will be perform RR rotation. And when we perform RR rotation, J becomes the root node and I is the left subtree of the node J and K is the right subtree of the node K. Okay. On inserting K, BST became unbalanced as the valence factor of I is minus 2. Since BST is a right skewed form, we will perform RR rotation on the node I. After performing RR rotation, the tree became like this. Okay. Then next we will be insert last, that is L. On inserting the node L into the tree is still balanced. When we insert L, L is in the same process. It will be compared with the every node those are present in this AVL tree. Node L is inserted at the right subtree right node of the node E. After inserting L, just calculate the valence factor of each and every node those are present in that AVL tree and you can see all the node having valence factor either 0 or plus 1 or minus 1. So we can see the tree is balanced. So in this case, we need not to rotate the tree because the tree is already balanced. So this is all about your AVL tree creation. So in our last video, we have seen that how can we create our AVL tree or how can we insert the node into the AVL tree and how can we delete the node from AVL tree. And in today's class, we just construct a AVL tree by inserting number of node into that AVL tree. So this is all about your AVL tree. So for the next video, till then keep watching. Thank you.